Ms. Fohart here. We are going to be reviewing a 5th grade skill today. We're going to be talking about coordinate planes and the first quadrant in a coordinate plane. I am using a PowerPoint off of iReady for the Ready Common Core that we're using. Learning target: represent real world and mathematical problems by graphing points in the first quadrant of a coordinate plane and interpret coordinate values of points in the context of the situation. All right, so we're going to be applying things that we've learned into real world problems today. All right, let's look at this problem. Mel has $10. He sells apples for $5 a bag. How much money does Mel have if he sells each number of bag? Okay, so looking at this, he has $10. He's starting out with that $10. So that's just money in the bank that he has. So I'm just going to write that as a regular green 10 because I know that he already has that. And then he sells apples for $5 a bag. Okay, so we know that we have one bag here, and one bag is $5. But he already has that 10. So we're going to kind of create an equation to represent that. So we know that we've got the $10 he already has, and it's going to add to how much the bag of apples cost. So I'm going to open my parentheses, and we're going to have our $5, and we're going to multiply it by the number of bags here. So we've got one bag. I'm going to put a 1 in that spot. Okay? And then I'm going to close my parentheses. Now, as you can see, we have different bags, and we can use this one example for all of them. Just plug in the number that goes here. So if I'm using my order of operations, remember back to your order of operations, PEMDAS, parentheses, exponents, multiplication or division, addition or subtraction. So we're still going to use that. So we're going to start off with our parentheses. We've got 5 times 1. What is 5 times 1? 5. Good job. So we've got 5, and bring everything else down without touching it. So now we've got 10 plus 5, and that will give us a total of $15. Now let's use the same thing for this next one. So like we said, Mel has a total of $10, and we're going to add that to how much the cost for his apples. So we have plus, open our parentheses, each bag is worth $5, and we're going to multiply that by the number of bags we have here, which is 2. So the 2 is going to go in the parentheses there. And now we need to go ahead and solve. Okay, so we start with our parentheses because it's the first thing, the P. We've got 5 times 2, which is 10. Bring everything else down without touching it. And we've got 10 plus 10, which gives us 20. So he has $20 when he sells 2 bags of apples. Now I'm going to do one last one with you, and then I'm going to have you do bag 4 by yourself. So for 3 bags, he starts off with his $10. We have to add it to how much the bags he sold. So we know that each bag is worth $5. And then we're going to multiply by the number of bags, which is 3. Okay? Then we're going to close those parentheses. So we're going to do our parentheses first. 5 times 3 is 15. I use that. Bring everything else down without touching it. And I've got 10 plus 15, which gives me 25. So if he sells 3 bags, he has $25. Now, I'm going to give you a chance. I want you to try 4 bags on your own. Now remember, if I go too fast, feel free to pause the video so that you can do this on your own and see if you get the right answer. Go ahead. All right, let's start off with how much money Mel has. Mel starts off with $10. All right, and we're going to add that Each bag costs $5, and we're going to multiply it by the number of bags we have, which is 4. And we're going to close those parentheses. Remember, we start with our parentheses. 5 times 4 is 20. I'm going to cross that out because I use it and bring everything else down without touching it. So we've got 10 plus 20, which would give us 30. So now that we kind of have an idea of what each bag would be and how much money Mel would have, we're going to try to see how this would look on a coordinate plane. Again, if I'm going too fast, pause. Feel free to write down all of the notes so that you have them for yourself. I'm going to continue moving. Move that over so we can see both parts. All right, Jenny has $20 saved in the bank. She earns $10 an hour washing cars and saves all of her money. Graph points in the coordinate plane to show the relationship between the numbers of hours Jenny works to the total amount of money she has saved. Include the following in your graph: the titles for the X and Y axis to show which quantity each axis represents, and points for 0, 1, 2, 3, 4, and 5 hours of work. Okay, so we've got to make sure first, it says we need titles. Okay, so we know that down here, since it's just single numbers, that's going to be our hours. And then going up, depending on her hours, we have how much money she is going to make. So we know that this on the side is going to be our money. All right, so now that we've labeled those, we can go ahead and see how they affect one another. All right, Jenny has $20 saved in the bank. So we know we're starting at $20, okay? So since she has $20 in the bank, she's always going to have that 20. We're always going to have to add that 20 to it, okay? She earns $10 an hour, okay? So we know for 1 hour she already has 20. So we're going to add 10 to that, which would give me $30. Because remember, she has 20, and we're adding that to the number of hours or her money she makes, right? She makes $10 an hour times her hours, okay? So the only thing changing in that equation is where that H is. And remember, that is what's on the bottom, or our x-axis. Our x-axis is horizontal and our y-axis is vertical, okay? So if I go for 2 hours, we know that she had $20, but then she's going to work 2 hours, so it's going to be another $10 on top of that. And if I plug it into my equation, we can see how that would work. So if I did 2 hours, let's just plug it in and see. She starts off with $20. We add that to her $10 an hour, and we're now doing 2 hours. So I'm going to plug 2 or use substitution in the place of that H. So we have $10 times 2, which is going to be $20, and bring everything else down without touching it. So we now have $20 plus $20, which gives me $40. Now let's see if that's the same thing we came up with over here. It is. It is the same thing. But it wants us to keep on going, right? So again, we know for 0 hours she has 20, and then it's just going to keep on going. So we know that it's just raising each hour by $10. From every graph, you can always come up with an equation. All right, we're going to take some more time and we're going to look a little bit more into this and practice these different equations. All right. For those of you in class right now, go ahead and take a minute, and I want you to ask a partner, why did you choose that strategy? the strategy I used to find the answer was, so these are just some sentence starters to help you. It's also some different things that can help you create questions, create conversations with one another. Because we do have to learn how to talk to one another appropriately and using the correct vocabulary words. So go ahead and pause this video and take a minute to do that. Now, as you were talking to your partner, y'all should have talked about how you can use an equation or create an equation given the information that we're always going to start and add that $20 onto our equation because she started out with the $20 in the bank. All right, so just like we've used a coordinate plane, we can also use a table, okay? The table shows the numbers of hours Jenny works and the total amount of money she has saved. So we have this, and if we go back and we look, we knew that our top numbers or our single numbers are hours, which was my x-axis, which makes our total money saved our y-axis. Now remember, your x always comes first in an ordered pair, just like your y always comes second in an ordered pair. So, looking at this, it's going to go into showing us a little bit more on how to graph it. Use the data in the table from the ordered pairs to graph the coordinate plane at the right. Show points plotted for the first two columns. So just like in our first one, we had this graph, and it gave us the ordered pair 130. All right, our next ordered pair was 240. The 2 representing the hours, the 40 representing our what? Money saved. Very good. So we would just keep on going, and then we would have 3 hours, and that would represent our $50 saved. All right, and we could keep on going on with that. So we can look at the first quadrant. This is our first quadrant where we have a positive y and a positive x. All right, we can create ordered pairs from that. We can also create tables from that. So whichever way is kind of easier for you, that's what I'm looking for, unless it asks for something specific. Here, it asks us to use a table with our ordered pairs so that we can graph them. We've got to make sure that we use exactly what it's asking us to do. All right, so now we're just kind of digging a little bit deeper into this. I want you to go ahead and pause this video and continue to work these out since I've gone over it with you, and I want you to fill in these blanks on your own. Go ahead. All right, so if you didn't have enough time, again, continue to work. Pause that video. I'm going to go ahead and go over it. So whenever you're ready, just unpause it and let's go over the answers. Okay, what does the x-axis represent? If we go back and look, we know that that x-axis represents hours, okay? Our y represents total money saved. All right, complete the ordered pairs, x, y, where the x is the number of hours, and then the y is the total money Jenny has saved. So we know that at first, when she just started off, she had $20. So for 0 hours, she was already at $20. For the first hour, we added 10 to that and got 30, and so on and so forth. All right, So now it's saying to plot the ordered pairs in the coordinate plane in the picture. So if you did not already do that, go back and plot those, and it should look like a diagonal line. How much money will Jenny have saved if she works 5 hours? So if we're looking at this, we know that the X stands for the hours, and the 70 right here, or the Y, is what stands for the total money saved. So we know that she saved $70. Which point on the graph shows this? Okay, so if you're looking at those points and we go back, we know that the order pair point that shows this is 570, because the 5 represents the hours and the 70 represents the total money saved. How many hours does Jenny need to work to have saved $40? Okay, so if we go up here, we know that the Y is our money saved, and we see 40 right here, so we know that she has to work a total of 2 hours to get up to the $40. Which point on the graph represents this? We already circled it up there, so let's go ahead and put the order pair here. So we've got 2 hours to our $40. Number 5, how can you use the coordinate plane to represent relationships between two real-world quantities? All right, so if we're representing these two things, the X and the Y work together to kind of show you how much that they show, or how much money that she makes. All right, if you need to take a minute to write all this down, or write any questions you might have off to the side so you can email them to me later, go ahead and pause and do that now. All right, let's look at this. Reflect. Look back at your Try It strategies by your classmates, model it and picture it. Which models or strategies do you like best for graphing points to show relationships between quantities in the coordinate plane, and explain. All right, now there's no right or wrong answer. You're just mainly looking at the different strategies we've used. We've looked at an equation. We've looked at a table. We look at using a coordinate plane. Okay, so pick the one that works best for you, and then I want you to write a sentence on that. So go ahead and take a moment and do that. All right, like I said before, no wrong answers here. I just wanted y'all to kind of talk and, get your brain moving about the different things that we used. Again, equations, the coordinate planes, the ordered pairs, the tables, all of them are useful in this skill. All right, let's go ahead and apply this now, okay? Fran works in an ice cream store. He uses 2 scoops of ice cream for each ice cream cone he sells. Make a table of values and then graph the points on the coordinate plane to show the relationship between the numbers of ice cream cones Fran sells and the number of scoops the ice cream he uses. Include the following in both the table and graph. Titles to show which quantity that represents the X and the Y values. Data for 0, 1, 2, 3, and 4 ice cream cones. All right, so I want you to go ahead and try this one on your own since I've done a couple with you and see what you understand and what you don't. Remember, while you're working through this, if any questions come up, write that question down so you can email me later and I can help you out. So go ahead and pause it and do that now. All right, I'm going to go ahead and go over that. So we know that he works in an ice cream store and we have 2 scoops for each ice cream cone. All right, so we have the number of ice cream cones here and we know that the one missing is the scoops. So we're going to put scoops here. So our scoops are our Y and our number of cones is our X, okay? So it says that it wants quantities for 0, 1, 2, 3, and 4. And that's for the cones. So I can go ahead and follow that in all the way through. So we start at 0, 1, 2, 3, and 4. Now, if I have 0 cones, do I have any scoops? No, I don't. So I'm just going to go ahead and fill that in with a 0. Now, it tells us up here that 2 scoops for each cone. So if I have 1 cone here, how many scoops do I have? 2. Very good. So if I'm looking at this, I see that I'm going from 0 to 2, and I'm adding 2. So each time, I'm going to add 2. So 2 plus 2 is going to be 4. 4 plus 2 going to be 6. 6 plus 2 is going to be 8. So we see that we're doing a repeated addition. What is something else we know that means the same thing as repeated addition? Multiplication. Good job. So we know that we can multiply by 2 each time. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. Okay? See how we can come up with those equations as well? You've got to kind of know how to have those equations. Now we have our chart or our table. Let's go ahead and put it in our quadrant or our coordinate plane. All right? So we need to label this. So we know that our x-axis, which is horizontal, is going to be my cones. So I'm going to just put cones. And we know my y-axis, which is vertical, is going to be my scoops. Okay, so now that I have that, I'm going to go ahead and create some ordered pairs here. So if I'm looking at this first one, remember our x comes first. So we've got 0 cones to 0 scoops. All right, if I'm looking here, I've got 1 cone to 2 scoops. And I'm going to keep on going. I've got 2 cones to 4 scoops. 3 cones to 6 scoops. 4 cones to 8 scoops. Okay, so now I'm going to go ahead and graph these. Remember, my x is the horizontal one. My y is my vertical. Remember, you've got to walk before you get on the elevator, which is up and down. Okay, so we're going to walk 0 and go up 0. So we're starting at 0, 0. What is 0, 0? Does anyone know? The origin. Good job. All right, so next we have 1, 2. So I'm going to walk 1 and then go up 2. So walk 1, up 2. All right. 2, 4 is walk 2, go up 4. So we always start at that origin. Walk 2, up 4. And we're just going to keep on going. Walk 3, up 6. Walk 4, and up 8. So your graph should look a little like that. If you need to take a minute to pause this video and write this down and check your work, go ahead and do that now. Use the table and graph in problem 7. Where would you put a point on the graph to show how many scoops of ice cream there would be for 5 cones? Explain your answer. Go ahead and take a minute, and I want you to add that 5th point on there. All right, and explain. Remember, when you explain, you have to write in a complete sentence. Capital letter, restate yourself, end with a period. All right, go ahead. All right, so right where we left off, we know that the last one we left off was 4, 8. So now we have to go to 5. Remember, our cones is our x, and we're increasing by 2 each time. So all we would simply do would be to add 2, and that would help us. So we know 8 plus 2 is 10. All right, so we could go ahead and explain that by saying 5 cones would have 10 scoops because each cone has 2 scoops. All right, and then we're going to end that with a period. All right, this is your exit ticket. This is the truth. See if you really were paying attention during this video. All right, I want you to go ahead and take a minute to answer this. Don't just guess. You need to show your work. That's how you truly know if you understand. All right, go ahead and work this one out. All right, so if we're looking at this, remember, our X represented our number of cones. Our Y represented our number of scoops. So if we're looking at this, remember our X is first and then our Y. So if I have an X of 2, that is how many cones? 2 cones. So if I'm looking through here, I know that I'm going to have 2 cones. A says 2 scoops of ice cream. Is that what we said? No, it's not. We're going to go ahead and cross that out. 6 scoops of ice cream are used in all. Are we supposed to be adding those 2 together? No. So we're going to cross that one out. 2 ice cream cones. Okay, we did say we needed 2 ice cream cones. All right, but let's look at our Y. What did we say our Y represents? Our number of scoops. So let's keep reading. 2 ice cream cones use 4 scoops of ice cream. Does that match up? Yes, it does. So our answer is going to be C. Let's go ahead and look at D and explain why that one is not correct. It says 8 scoops of ice cream are used in all. They got that 8 by multiplying those 2. We're not multiplying the X and the Y. They're 2 separate things. All right? Hey, if you got that right, good job today. Way to put in the work. If you have any questions that you may have written down during this video, please email me so that I can help you out with those. Keep working on some practice problems so that you can understand this really well. Good job today, guys.